Symmetry.
Introduction. Symmetry is an important geometrical concept commonly exhibited in nature and is used almost in every field of activity. Artists, professionals, designers of clothing or jewelry, car manufacturers, architects, and many others make use the idea of symmetry. Architecture, engineering, nature. Architecture, engineering, nature. Example: the beehives, the flowers, the tree leaves, religious symbols, rugs, and handkerchiefs. Everywhere you find symmetrical designs. A figure has a line symmetry if there is a line about which the figure may be folded so that the two parts of the figure will coincide. Let us now strengthen our ideas on symmetry further. Study the following figures in which the lines of symmetry are marked with dotted lines. Symmetry. A figure is said to be symmetrical about a line if it is identical on either side of line. In this case, line is called the line or axis of symmetry. Example: symmetry of line segment. A line segment is symmetrical about its perpendicular bisector. Symmetry of angle. A given angle having equal arms is symmetrical about the bisector of the angle. Symmetry of isosceles triangle. An isosceles triangle is symmetrical about the bisector of the angle included between the equal sides. Symmetry of rectangle. A rectangle has two lines of symmetry, each one of which is the line joining the midpoints of opposite sides. Symmetry of rhombus. A rhombus is symmetrical about each one of its diagonals. Symmetry of Square. A square has four lines of symmetry, namely the diagonals and the lines joining the midpoints of its opposite sides. Symmetry of Equilateral Triangle. An equilateral triangle is symmetrical about each one of the bisectors of its interior angles. Symmetry of Circle. A circle is symmetrical about each one of its diameters. Symmetry of English alphabet. Each of the following capital letters of the English alphabet is symmetrical about the dotted line or lines as shown, and so on. Rotational symmetry. A figure is said to have rotational symmetry if it fits onto itself more than once during a complete rotation. A number of times a figure fits onto itself in one complete rotation is called the order of rotational symmetry. Example: let us rotate an equilateral triangle through 120 degree, 240 degree and 360 degree to attain the positions shown in figures. Original form. Rotated through 120 degree, rotational symmetry of order 1. Rotated through 240 degree, rotational symmetry of order 2. Rotated through 360 degree, rotational symmetry of order 3. Clearly, each of the three times the figure fits onto itself, so it has a rotational symmetry of order 3. Example: let us rotate a square ABCD through 90 degree, 180 degree, 270 degree and 360 degree to attain the positions shown in figures. Original form. Rotated through 90 degree, rotational symmetry of order 1. Rotated through 180 degree, rotational symmetry of order 2. rotated through 270-degree rotational symmetry of order 3, rotated through 360-degree rotational symmetry of order 4. Clearly, each of the 4 times the figure fits onto itself, so it has a rotational symmetry of order 4. Note, rotation turns an object about a fixed point. This fixed point is the center of rotation. The angle by which the object rotates is the angle of rotation. A half turn means rotation by 180 degree. A quarter turn means rotation by 90 degree. Rotation may be clockwise or anti-clockwise. Line symmetry or rotational symmetry. You have been observing many shapes and their symmetries so far. By now, you would have understood that some shapes have only line symmetry, some have only rotational symmetry, and some have both line symmetry and rotational symmetry. Example 1. Consider the square shape. Have both line symmetry and rotational. Line symmetry, rotational symmetry. Example 2. The circle or circle pattern is the most perfect symmetrical figure because it can be rotated around its center, that is, every diameter, through any angle, and at the same time it has unlimited number of lines of symmetry. And so on. Note, some shapes have only one line of symmetry, like the letter E. Some have only rotational symmetry, like the letter S. And some have both symmetries, like the letter H.